Hey, what's up everyone? Sean here and welcome to another new video about random things with random facts. Now in today's video I'm going to be covering one of my favorite passions in the world, which is photography. So I'm going to be doing a bunch of random facts about photography. Without further ado, let's go ahead and get into it. Now before I begin, as always, I pull all of these facts from Google, so they're sourced 100% for accuracy for that part of it too. If I cannot pronounce a word, I will spell it out for you guys as well, and just go slowly with it as well, and kind of rephrase it if I need to. If you have any comments about anything I go through or comments about, as far as just giving more information about it, just feel free to comment about that below. Thanks for watching as always, and let's go ahead and get into it. So here we go, random facts about photography. Here we go. Alright, photography is the science and art of recording light. The word photography comes from Greek words meaning drawing with light. Visible light is a form of electromagnetic radiation. Visible light has wavelengths of approximately 380 to 700 nanometers. Also, I do pull scientific facts more than normal facts to make it more interesting for you guys too. So some of these words might be a little bit out there for what they are, and that's why I always enjoy helping you guys in the comments too. So again, otherwise I pull in a lot of basic things that you may already know. So I try and pull in more scientific stuff to make it more interesting too. Different wavelengths are perceived as different colors. White light contains many wavelengths mixed together. Light travels at about 299,792 kilometers or 186,282 miles per second in a vacuum. Light slows down when passing through glass. Lenses bend light through refraction, R-E-F-R-A-C-T-I, when refraction. Refraction occurs because light changes speed between materials. Convex lenses converge light rays. Camera lenses use multiple glass elements to reduce optical distortions. Reflection occurs when light bounces off a surface. Matte, M-A-T-T-E, matte surfaces scatter light in many directions. Mirrors produce specular reflection. Diffuse lighting creates softer shadows. Hard lighting creates stronger shadows. The angle of incoming light affects the appearance of texture. Polarized light vibrates mainly in one direction. Polarizing filters reduce reflected glare. Light intensity decreases with distance. This follows the inverse square law. Doubling the distance from a light source reduces illumination to 1/4. Light interacts differently with transparent, translucent, and opaque materials. Every photograph is fundamentally a measurement of reflected or emitted light. A camera lens focuses light onto a sensor or film. The focal length determines a lens's angle of view. Short focal lengths produce wider fields of view. Long focal lengths produce narrower fields of view. Wide-angle lenses exaggerate perspective. Telephoto lenses compress apparent distances. Aperture is the adjustable opening inside many lenses. Aperture size is measured using f numbers, f as in Frank numbers. Smaller f numbers represent larger openings. Larger apertures admit more light. Smaller apertures increase depth of field. Depth of field is the range of acceptable sharpness. Lens sharpness varies across the image. Most lenses are sharpest a few stops below maximum aperture. Optical aberrations, A-B-E-R-R-A-T-I-O-N-S, aberrations reduce image quality. Chromatic aberration occurs because colors refract differently. Spherical aberration affects image sharpness. Lens coatings reduce reflections. Anti-reflective coatings improve contrast. Camera lenses may contain over 20 optical elements. Aspherical, A-S-P-H-E-R-I-C-A-L, aspherical lens elements reduce distortion. Lens design balances many competing optical factors. Zoom lenses provide variable focal lengths. Prime lenses have a fixed focal length. Every lens produces a unique optical signature. Digital cameras use electronic image sensors. Most sensors are either CMOS, CMOS, or CCD. CMOS sensors dominate modern cameras. Sensors convert light into electrical signals. Individual sensor elements are called pixels. Each pixel measures incoming light. More pixels increase image resolution, but not necessarily image quality. Pixel size influences light gathering ability. Larger pixels generally collect more light. Better light collection improves low light performance. Most sensors use a Bayer, B-A-Y-E-R, Bayer color filter array. Each Bayer pixel records only one primary color. The camera estimates missing colors using an interpolation, interpolation. Interpolation. This process is called demosaicing, D-E-M as in Mary, O-S-A-I-C-I-N-G. I don't know what that is. Image sensors are made from silicone. Silicon is sensitive to visible light. Sensors also detect some infrared light. Infrared blocking filters are commonly installed. Quantum efficiency measures how effectively a sensor converts photons into electrons. Modern sensors have high quantum efficiency. Sensor temperature affects image noise. Cooling reduces electronic noise. Scientific cameras are often actively cooled. Sensor technology continues to improve each year, which it does usually. Image quality depends on both sensor design and lens quality. Exposure depends on aperture, shutter speed, and ISO, so ISO, the letters. These three settings form the exposure triangle. Aperture controls how much light enters the camera. Shutter speed controls how long light reaches the sensor. ISO controls the sensor's amplification of the signal. Faster shutter speeds freeze motion. Slower shutter speeds capture motion blur that we all have seen with like waterfalls and stuff. I'm adding that. Motion blur depends on subject speed. Camera movement also creates blur. Tripods reduce camera shake. Image stabilization compensates for small movements. Exposure is measured in stops. One stop represents doubling or halving half the amount of light. Histograms display brightness distribution. Histograms help evaluate exposure. Overexposure clips highlight detail. Underexposure reduces shadow detail. Dynamic range describes the brightness range a camera can capture. Modern sensors have wide dynamic range. Human vision has even greater adaptive dynamic range. Exposure meters estimate scene brightness. Reflective metering measures light bouncing off subjects. Incident metering measures light falling onto subjects. Different metering modes prioritize different parts of the frame. Proper exposure depends on the artistic intent as well as physics. Yeah. Cameras record color using red, green, and blue channels. Human vision also relies on three cone cell types. White balance compensates for different light sources. Daylight and tungsten, Tungsten, bulbs have different color temperatures. Color temperature is measured in kelvins, Kelvins, kelvins. Candle light is relatively warm in color. Blue skies have higher color temperatures. Cameras estimate white balance automatically. RAW, R-A-W, RAW files preserve more color information than JPEGs. JPEG files use lossy, L-O-S-S-Y, compression. RAW, R-A-W files contain minimally processed sensor data. Color spaces define how colors are represented. sRGB is the most common color space. Adobe RGB includes a wider color gamut. G-A-M-U-T is color gamut. Pro Photo RGB includes an even larger gamut. Not all monitors display the same colors. Monitor calibration improves color accuracy. Color management ensures consistency across devices. ICC profiles describe device color characteristics. Human color perception depends on surrounding colors. Simultaneous contrast alters perceived color. Cameras record light objectively, but color perception is subjective. Different lighting changes color appearance. Shadows often contain reflected environmental colors. Accurate color reproduction requires both science and calibration. Do a few more here. Sharpness depends on focus accuracy. Diffraction, diffraction, diffraction limits optical resolution. Very small apertures increase diffraction. Every optical system has a diffraction limit. Image noise increases in low light. Noise originates from electronic and photon-related sources. Excuse me. Photon shot noise is fundamentally random. Signal-to-noise ratio affects image quality. High signal produces cleaner images. Long exposures increase thermal noise. Dark frame subtraction reduces long exposure noise. HDR photography combines multiple exposures. HDR increases capture dynamic range. Focus stacking combines multiple focus distances. Panorama stitching combines overlapping images. Computational photography uses algorithms to improve images. Smartphones rely heavily on computational photography. Artificial intelligence assists noise reduction. AI also improves image sharpening. Modern cameras perform real-time image processing. Compression reduces file size. Lossless compression preserves all image information. We'll finish up here. Image editing alters pixel values mathematically. Digital photography depends heavily on computer science. We'll do a few more, we'll finish up. Infrared photography records wavelengths beyond visible red. Ultraviolet photography records shorter wavelengths than visible light. X-ray imaging is a specialized form of scientific photography. Astrophotography captures distant celestial objects, so space. Long exposures reveal faint stars and galaxies. Planetary photography often uses thousands of stacked images. Macro photography reveals tiny details. Microscopy combines optics and photography. High-speed photography freezes extremely fast events. Some cameras record millions of frames per second. High-speed photography reveals invisible physical processes. Time-lapse photography compresses long events into short videos. And lastly, we'll hear slow plant growth becomes visible through time-lapse. And last one, aerial photography uses aircraft or drones. So that was a lot of fun stuff. Actually, I learned quite a bit in that one for photography. I love photography. On the personal side, just doing basic photos and things like that. But hopefully you also learned something. Comment if you did or not. Thanks for watching as always. For just again, fun random facts about photography. If you enjoyed the video at all, give it a thumbs up, and of course subscribe for much more random fun facts about things. And then comment below what you would like me to do a video on for random facts about whatever it might be in the world. Again, thanks for watching as always, and I will see you all in the next one.